idea of electricity and thinking about electrical circuits. So far, we've had electrical circuits which have looked really, really sophisticated, pretty much like so. And that's really been about it. And we've said we've got a voltage, a supply of some sort, so let's go for 240 volts, and we've put a resistance into it. And really that's been about it. But those of you that have thought about this for more than half a second will realise that most electrical circuits don't look like that. For example, if you look at the lights in this room, there's 4 lights in a row up there, and there's not a great big power supply between each of them. So what you've actually got is you've got a switch on the wall over there. You've got that switch, which can be off or on, and then you've got a whole bunch of, in this case, lights, which are effectively just a form of resistor. They give out their energy as light, so you turn it on, energy flows, the resistors turn that energy into light, gives out the light, and away we go. So we've got these 4 resistors, and let's just make up a number. So we'll say they're all 100 ohm resistors. 100 ohms, that's possibly the worst Amiga I've ever drawn. 100 ohms, 100 ohms. Okay, so we've got all these 100 ohm resistors. And the question we want to be able to the question you want to be able to answer, play with, is how can we apply Ohm's law to this? So Ohm's law is V equals IR. We know what the voltage is for the whole thing, but what's going on with the resistance for the whole thing? The key with Ohm's law is it works between points, between 2 points. Let's just shut my circuit up so the current's actually going to flow. That's circuit, current flowing around the circuit. Key thing with Ohm's law is you must, whenever you want to apply it, you've got to think about which 2 points am I applying it between. So if I apply it between here and here, if I go around this way, then the current is whatever I is. The potential difference, the voltage difference between here all the way back around to here is your 240 volts. As you go through the battery, it gets recharged. So you've got your 240 volts between here and all the way around to here. So the resistance I'm interested in is the total resistance I go through. So it's that one, and that one, and that one, and that one, back to the start. Okay? So I've got the situation where somehow or other, I need to be able to join these 4 resistances and treat them as a single resistance. And the formula is as simple as you hope it's going to be. The total resistance across here is 100 plus 100 plus 100 plus 100. So the total resistance around this circuit is 400 ohms. Okay, so there's a formula that just says that resistance is R1 plus R2 plus R3 plus R4. Yep. So we've got those 4 resistances. So in this case, that's just going to be equal to 400 ohms, okay, for that whole circuit, which means we can now apply Ohm's law to work out the current. So I is V divided by R is 240 volts divided by 400 ohms is 0.6 amps is going to be the current that will flow in that circuit, because the resistance, as we go through these 4 resistors, is just the sum of the 4 resistances. Word of warning, these are joined in what's called series. The next video I'll talk about other ways of joining them, but series means the current has no choice. It has to go through each of them. And as long as the current has to go through each one, then we can just add them all up. The resistance is the total of going through the whole thing. Okay, so these are what we call resistors in series. It just means one after the other. There's no branches, there's no choices for the current. And in that case, the key idea is that the total resistance is just all the bits of resistance added together. Okay? Resistors in series.